Hello, this is the first video for Math0302 beginning Algebra Chapter 5, Sections 5 and 6. It's called Negative Exponents and Dividing Polynomials. Again, I still have a cold, so try to bear with me. Okay, so we want to use the quotient rule to simplify this exponential expression. It's a squared divided by a to the sixth power. Now, using our quotient rule, we just take the difference of the 2 minus 6. And 2 minus 6 gives me negative 4. So a squared over a to the sixth means the same thing as a to the negative 4 power. However, you'll find that we never want you to leave something with a negative exponent. Okay? So what we do is we can write this a squared divided by a to the sixth as a times a divided by a times a times a times a times a times a. Now notice that because all of these are factors, this a cancels with this a, and this a cancels with this a. So notice what we're left with. In the numerator, everything cancels, so I'm left with 1. In the denominator, I'm left with a times a times a times a, which is a to the fourth power. Okay, so what that means is that a to the negative 4 must be equal to 1 over a to the fourth power. Okay, so a to the negative 4 is equal to 1 over a to the fourth power. Says when a base is raised to a negative exponent, write the base as its reciprocal and change the sign of the exponent. Now notice a negative exponent does not change the sign of the base. Another thing to keep in mind, what I like to say is when you have a negative exponent, it moves to the other side of the division sign. Now I can write this as over 1 over here. Because it has a negative exponent, I can move it to the denominator and change the sign of the exponent to positive. So anytime it flips to the other side of the fraction, the exponent flips signs as well. Okay. Now notice that that's only the exponent that changes its sign. Alrighty, let's use this. 5 to the negative 2 actually means the same thing as 1 over 5 squared. Think of it this way. This entire thing moves to the denominator, but change the exponent to positive. And then you simplify. So this is going to give me 1 over 25. And we have to be careful here, because a lot of people might say negative 25. And that would be wrong, because first of all, they didn't flip the base, which is 5, and so the reciprocal will be 1 over 5. But then this exponent being negative doesn't change the sign, so it's just 1 over 25 here. Okay, let's look at 3y to the negative fourth power. Okay, here's the thing. What's the base here? The base is just y, because the very first thing to the left of the negative 4 is y. So this is going to give me 3, and then because we have y to the negative 4 here, I'm going to move this to the denominator, so it's going to be 3 divided by y to the positive fourth power. So it is 3 divided by y to the fourth power. There you go. Let's look at c. With c, what's the base? Well, the base is negative 5. So this time I'm going to make this 1 over the base, which is negative 5, and then change the sign of the exponent, squared. And then you simplify. Negative 5 squared is 25. So this is 1 over 25. Okay, let's look at d. X to the negative 3 divided by x to the negative 5. Well, that's the difference, the quotient formula, so we need to take the difference of the exponents. It's always the first minus the last, or the top minus bottom. Negative 3 minus negative 5 is negative 3 plus 5, which gives me x squared. Now that's one way of doing this. If we want to, we could actually flip each of these. This -5 can go to the numerator, and this -3 can go to the denominator and change their signs. So that becomes x to the 5th divided by x cubed. Notice that 5 minus 3 is 2. And this is another way that we can get to x squared. Now let's look at e. Again, quotient property means we take the difference of the exponents with the top minus the bottom. So we have -5 minus 7. -5 minus 7 is -12. And a negative as an exponent means we move it to the denominator and change the sign to positive for the exponent. So x to the -5 divided by x to the 7th is 1 over x to the 12th. Now there's another way that we could do this. We can make this to be, because this is x to the -5 of the numerator, move it to the denominator, making that 1 over x to the 7th times x to the 5th. So now we're multiplying like bases. When you multiply like bases, you add the exponents. So this would be 1 divided by x to the 7 plus 5. And 7 plus 5 is 12, which will again give you 1 over x to the 12th. For these types of problems, you can just do whichever one it is that feels the best, really, because they're equivalent to the same thing. Just make sure in the end the exponent is positive. Okay. And also make sure you box your answers, please. Alrighty, I'm going to go ahead and end it here, and I will see you in the next video.